Welcome to solverfy.
Okay, so in this situation, we have a lighted candle and two converging lenses, and we want to first draw the ray diagram and estimate the location and relative size, and then do the actual calculation. So both of them are converging lenses, so the light ray will converge to the focal point, and we have the information where is the focal point. This is f1 and f1 prime and f2, f2 prime. So if we have a light ray coming parallel from the top of the candle, we'll hit the converging lens, and then the ray will converge to the focal point and generate the image here. So the image of the candle will be here. And now this becomes the object for the second lens. So for the second lens, the light will pass through the focal point. It should be a straight line. So let's try to do it again. So the light passes through the focal point, and because it passes through the focal point, it will become parallel again. So it will go like this. And then here will be the image of the candlestick after passing through the second lens. And now, if you want to do the actual calculation, we can use first in this first section here, we need to find this distance. So the relation is the 1 over distance of the object at the lens 1 plus 1 over the distance of the image at the lens 1 is equal to 1 over the focal point on the lens 1. We can solve this for the distance of the image to find this distance here. So this gives us distance is equal to distance of the object times the focal point divided by distance of the object minus the focal point. And we have all this information. So this is 36 centimeters times 13 centimeters times divided by 36 minus 13. And this gives us 20.35 centimeters. So the object is placed 20.35 centimeters from the lens 1. Now we know the distance between lens 1 and lens 2, so the actual distance for the lens 2 will be 56 minus 20.36. So the distance of this guy, considering an object now, so the distance of the object 2, so this distance from here to here, is 56 minus 20.35 is equal to 35.65 centimeters. And now with this distance, we do it the same formula again for the second lens. So let's do this in other page. And we have that 1 over the distance of the object plus 1 over the distance of the image is equal to 1 over the focal point. And again, solving for the image, we get distance of the object times the focal point divided by the distance of the object minus the focal point. And this is 36.65 times 16 centimeters divided by 36.65 minus 16, and this is 29.35 centimeters. So the final image is at 29.26 centimeters from the second mirror, and the image is real, so it is real, and we can work out the total magnification of the lenses, because it's just the product of the two magnifications. So we have that the magnification is magnification of the first lens, magnification of the second lens, and this is the ratio between the image and the object. So this is minus the one image, the one object, the two image minus the two object, and this is 0.46. So the image will be smaller than the initial image, but it will be a real image, and from this distance from the mirror.